In an electrical circuit with EMF ET resistance R and inductance L, the current I builds up at the rate given by N into di by dt plus R into I equals to ET if the switch is connected at t equals to 0 and disconnected at t equals to a. Find the current at instant. So friends, we have I equals to 0 at t equals to 0 and ET equals to E for 0 less than t less than a and 0 for t less greater than a. So taking the Laplace transform both sides, I just take Laplace transform both sides. So whatever I get, Ls, in this case I get L into S plus R into I. Okay, I equals to 0 and Ls into I di by dt. So equals to 0 to infinity e to the power minus st et dt equals to 0 to a e to the power minus st e dt equals to e by s into 1 minus e to the power minus as. Okay, I just take Laplace. After that I just use inversion. So I equals to at first I find out E divided by S into capital Ls plus R minus E into e to the power minus S divided by Ls plus R. So I equals to, just using inversion, Laplace inversion, I equals to L inverse so friends, in here it is I bar. This is the best way. Laplace is I bar. Okay, so S I bar, so I equals to L inverse E divided by S into Ls plus R minus E into e to the power minus S divided by S into Ls plus R. So this is the total Laplace inverse. Okay, just Laplace inverse. Now I have to find out. So friends, you see that total calculation I have already done, that L inverse E divided by S into Ls plus R is equal to this is, and L inverse e to the power minus S is equal to ut minus 1 shifting property. This property is called shifting property, and after that I just put in the value, and when 0 to this value will be whole, and when t less than 1, then this equation is my current. My current is this equation. Thanks for watching. I hope I can clear the unit, step function and with application.